Good morning, everyone. So it is paper number 4. Here we have 10 short questions, 5 from pure and 5 from applied. Then I've given you 4 essays, 2 pure and 2 applied. I hope to increase the questions soon. By the way, the time frame for 10 short questions and 4 essays is 2 hours. Thereby, I expect to complete all the 10 questions within 40 minutes. Means that for one short question, roughly 4 minutes. Then for the four essay questions, you have 120 minus 40, 80 minutes. Means you have to practice to complete an essay within 20 minutes roughly. Right? So we'll start with question number 1, short question. Question number 1. It is a limit. Limit x tends to 5 by 4. X tends to 5 by 4. 1 minus sine 2x over 5 minus 4x cos 2x. And they have given show that as well. You have to lead this to that answer. By the way, what is better? You know that it is the basic trig limit. Yeah, we proved limit x tends to 0, sine x over x is 1. That is what we have to apply here. By the way, by directly substituting limit x tends to 0, sine x over x, it was not defined 0 over 0. That is why by using a geometric method, we prove the value is 1. So what you need to do is, here also, limit x tends to 5 by 4, when you try to substitute directly, it is also going to be 1 minus sine 1 minus sine 2 into 5 by 4, sine 5 by 2, 1 minus 1, 0. Over 5 minus 4x is 5 minus 5, 0, plus 5 by 2, 0. Everything is 0. Everything is 0. Then sure. Give me a second. Right. That is why by directly substituting, you can't evaluate this answer. You can't evaluate this answer of the limit or the limit. Then what you need to do is you have to find that issue is that limit x tends to 0, sine x over x is hidden here. You have to find out that by using most of trigonometry, sometimes algebra, and get it substituted to 1. That is what you need to do. Clear? So the thing is, usually the limit x, which is the variable, tends to some other value other than 0, this is going to be comparatively hard, except for some of questions. Right? So what we usually do is, we have to go for a substitution. When this x tends to some value, we have to find that find out that variable which tends to 0. So let us start. We can say when limit x tends to 5 by 4, limit x minus 5 by 4 tends to 0. We substitute x minus 5 by 4 as 3. So we can see here x minus 5 by 4 is 3. Clear? Now let us update this. Limit e tends to 0. Limit e tends to 0. E tends to 0. 1 minus sine 2x. 1 minus sine 2. What is x? 5 by 4 plus t. 5 by 4 plus t. Over 5 minus 4 is x minus 5 by 4 is t. Let us multiply everything with 4. 4x minus 5 is 40. 4x minus 5 is 40. 5 minus 4x is minus 40. Into cos 2x. Cos 2 into x. 2 into x is again 5 by 4 plus t. Alright, next step. You can take this minus 4 out. So it is minus 1 by 4. Limit t tends to 0. Here 1 minus sine 2 into 5 by 4 is 5 by 2. You have to do this because always a multiple of 5 by 2 plus some angle or minus some angle will give you the derived angle. Instead of like 45 plus, you have to apply then a plus b or a minus b. That is why 5 by 2 plus 2t over minus 4 goes out, was taken out, t. Because again, here also you multiply with 2, 5 by 2 plus 2t. Right, next step. Minus 1 by 4, limit t tends to 0. Sin 90 plus angle is cos angle. So 1 minus cos 2t over t. Cos 90 plus angle is sin angle. So it is cos 90 plus is second quadrant minus sin 2t. Alright. This minus can be taken out for the next step. It is going to be 1 by 4. Limit t tends to 0. There is no point. There is no point of keeping. There is no point of keeping cosines. You need to search for that sine over here in particular sine t over t to get rid of that 0 over 0 undefined value. So limit t tends to 0. 1 minus cos 2t according to power reduction is 2 sine square t. Okay. 2 sine square t over t sine 2. T sine 2. What you have to do to find that sine t over t? Get both numerator and denominator divided by the maximum power of sine, which is 2. Right. So let us take 2 out as well at the same time. 2 over 4. 1 over 2. Limit t tends to 0. Sine square t over t square over. I'll separate the limits at the same time. Limit t tends to 0. Sine 2t over t. Why? Dividing by t square, cancelled out 1t. Now the next step right away you can have find the answer. Limit t tends to 0. Limit of the power is power of limit. So find t over t totally square over. There you have sine 2t. So limit 2t tends to 0. Sine 2t over 2t. You multiply denominator by 2, so you have balance. Numerator of the denominator by 2 should be there as a multiplication. Right. So here you have mentioned because of that limit 2t tends to 0 as well when limit p tends to 0. You have to change everything and write down the answer accordingly. Right? You have to be smart to reduce the number of steps because you know that the space is very limited. So I'm here explaining. You have to be smart in reducing. In classes, I've taught you how to reduce, right? So final answer 1 over 2 over 2 is 1 over 4. Meanwhile, this is 1 and this is 1. That is the answer. How I got to 1. Clear? If you have any issue, any problem, please don't hesitate. Just turn on your mic and ask that. Okay, now you can do the corrections. Those who have done well, I saw in the classes as well. Really good. You have been improving. Yeah, that is also okay. Instead of power reduction, you can multiply 1 minus cos to t in particular by 1 plus cos to t for both the sides. Usually we multiply the conjugate of the denominator, that is in that rationalizing case. But here, in finding that sign over the variable, you, yeah, you would do that. That is also right. The second one, second question. First one is done. The second question I've given you, yeah, it is about arrangements, permutations and combinations. Permutations and combinations. Seems like not that much of hard question. Let's see. Question number 2. There, question number 2. There, showing a certain country, her registration digits consists of 3 letters. It is not so. In a certain country, please cut show. In a certain country, her registration digits consists of 3 letters followed by 4 numbers. 3 letters and 4 numbers followed by 4 numbers. So these are letters. These are letters. And the other 4 numbers. These are numbers. The number. Right. How many registrations are possible if no letter or digit may be repeated? You can't repeat anything. Ne? They are. This is what you have to do. In part 1, number of ways of arranging letter. It's about arrangement. To have a particular registration number, it is about arranging. Number of ways of arranging letter. There you have to separately arrange because the numbers are followed by, just like in Sri Lanka, we also have this number for the registration. Usually 3 letters and 4 numbers. So you cannot mix up between the numbers and letters. First 3 letters, then followed by 4 numbers, right? So number of ways of arranging letters. As this is a short question, you don't need to write down the separate sentences for selecting letters and arranging separately. So right away you select and arrange. There are number of ways of arranging letters. You have in alphabet 26 letters. So 3 should be chosen. So 26, 26, 63. You choose 3 letters and you have to arrange them in between. You have to arrange them in between. And according to those two, accordingly, you write down accordingly number of ways of arranging numbers. So how many digits you have in we are dealing with base base to 10 base. So you have 10 digits. So out of those 10, you can pick 4. 10 C4, pick 4 and arrange between them. So this is going to be the final answer for part 1. Final answer for part 1. Right. So as I have told you, you can also use blank filling method. But when you have without repetition, you can even use the normal way. With repetition, I recommend the blank filling method. By the way, let's see. So the final answer here, you can see, therefore, 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 total arrangements, therefore total arrangements according to counting theorem. So how many? 26 C3 into 3 factorial, 10 C4 into 4 factorial. That is going to be the final answer. Yeah, you have to calculate it then. Write down the final answer here. 26 C3, 26 factorial over 23 factorial into 3 factorial into 3 factorial. 10 C4 means 10 factorial over 4 factorial into 6 factorial into 4 factorial. 3 factorial to 3 factorial, 4 factorial to 4 factorial cancelled out, and you'll have the final answer. Anyone calculated? You can give me the answer, then others can check. That is how you need to calculate. Under numbers, do we consider 0 as real? Yeah. The thing is this. This is not that, this is a good question. You know that when we form numbers, that is why I mean, I didn't consider it automatically by knowing a number. By the way, I need to discuss about that as well. When you like form a number with 4 digits, for example, when 0 comes to the first digit, 434 is not 4-digit number. 434 is accepted, and that is 3 digits number. So once 0 comes first, that 0 is, I mean, not considered as a digit for that number. Again, for example, once you have 438, it is just 430, 3 digits number, not 4 digits number. By the way, for registration, practically, it is just a registration number. It doesn't matter, 0 comes first, or the second, third, or fourth, it doesn't matter. Critically, yes, as the critical condition, when 0 comes to first digit is the matter. But here it doesn't matter. That is it. You can have the final answer here after simplifying, as I've told you. For the second part, number of ways of arranging letters, there we'll follow. Here also we can follow that. Black filling 26, 25, 24 accordingly, 10, 9, 8, 4. Right? So in the second answer, I'll not write down the steps again, but by the red pen, I'll write down the answer for the steps accordingly. So it is going to be 26 ways to fill the first, again 26 ways to fill the second, again 26 ways to fill the third. Because repetitions are allowed, it doesn't matter. They are being the same letter or even not, doesn't matter. Right. So here, what should be the answer? 10, 10, 10, 10. Doesn't matter. It gets repeated. So what you have to have as the final answer is 26 to the power 3 into 10 to the power 4 with the simplification, right? So that is going to be the answer for the second part. Please complete with the answers. If you have any issue, please ask. All right. The third question. Question number 3. So, what I have given you question number 3 is yeah, the lesson straight lines. All right. There, ABCD is a parallelogram. The equation of the side AB is, and the diagonals meet at the point 2, 1. The line x plus 3 equals 0 passes through the point A. Find the coordinates of C and the equation of side DC. Question number 3 is the ABCD is a parallelogram. A, B, CD is a parallelogram. ABCD is a parallelogram. The equation of the side AB is x plus y plus 2, 0. So here it is x plus y plus 2, 0. And diagonals meet at the point 2, 1. Diagonals meet at the point 2, 1. So let us say that is E. Now the diagonals are bisected in parallelogram. Further, the line x plus 3 equals 0 passes through the point A. X plus 3 equals 0. When x plus 3 equals 0 passes through the point A, what about the x coordinate of point A? It's just x equals minus 3. That is the x coordinate. We don't know about the y coordinate. That is it. Further, find the coordinates of C and the equation of the side DC. Coordinates of C and the equation of side DC. Coordinates of C and the equation of side DC. Coordinates of C, equation of side C. What is it? Right. In a side, I write down the question. Then again, I don't need to write take the answer. That is why. By the way, so what you can do, you can write away design coordinate the full coordinates. I mean, you know x coordinate of A. By the way, as the equation of AB is x plus y plus 2 equals 0, it should be satisfied by coordinates of A. So you have to say, then you can find y any as x plus y plus 2 equals 0 is satisfied by A, which is minus 3 ya, minus 3 ya, minus 3 plus ya plus 2 is 0. Ya is going to be 3 minus 2, 1. Therefore, A, coordinates of A is minus 3, 1. Then, yeah, by using external division, no internal division, you can say A is divided by C externally or AC is divided by E external. By any means, you can find the coordinates of C. So I'll get this done by external division. You can say by external division, C is going to be here. So what about the ratio? 2 to 1. 2 to 1. 2 happens from minus 3, 1 and 1 happens from 2, 1. So you have to cross multiply. I mean, the scenario is like cross multiply. 2 into 2, 2 into 2 minus 2 into 2 minus 2 into 2 minus here C is divided. It should not be this one. It should be this one. Why is that? You have to mark the ratio where C divides E. C divides A to 2, C divides E to 1. That is why. So 2 to 1 is generated by E, minus 3, 1 is generated by 2. So 2 into 2, 1 into minus 1 into minus 3 over 2 minus 1. Come on. 2 into 1, 2 into 1 minus 1 into 1. 1 into 1 over 2 minus 1. So C is going to be 4 plus 3, 7, comma 1 over 1. That is C, coordinates of C. Then equation of CD, you can easily have that afterwards. Because as CD is parallel to AB, gradient of CD, you can calculate them. So you can see as CD is parallel to AB, gradient of CD is -1. Therefore, equation of CD. Now you have to find the equation of CD. How to find the equation of CD? How to find the equation of CD? Yeah, it is by generally defining a point. In a short question, you don't need to mention that. You just need to say, yeah, y minus 1 now x minus 7. Y minus 1 over x minus 7 is minus 1. So, minus x plus 7 is y minus 1. X plus y minus 8 equals 0 is the equation of CD or DC. Okay, so that is it. Those who have completed all okay. Those who haven't completed done it wrong, you can do the correction. All right. We'll move to question number 4, which is from circle, the other part of this orbital geometry. Let's see what we need to do. All right. Question number 4. This is the circle. They have given the equation and P is the point. So that the point P lies outside the circle. Right. So they have given the circle to be. Question number 4. They have given the circle to be x squared plus y squared minus 4x minus 2y plus 4, 0. And P is the point. By the way, you know that to decide the point is whether outside or the circle or inside, you have to compare the radius with the line length which is connecting the center of the circle and that particular point. By the way, so that you have to find out the properties of this circle. You can complete the square separately for x and y. So it is going to be x minus 2 square. X squared minus 4x plus 4 minus 2. Then for y minus 1 square. So it is going to be y squared minus 2y plus 1 minus 1. And for the constant, it is plus 4. Let's see. Further, this is going to be x minus 2 squared plus 1 minus y minus 1 squared minus 4 plus 4 minus 1 to the other side is 1, which is 1 square. Therefore, you can say center, let us take it as C for the circle is 2, 1. Radius, let us take it as R is 1. Clear? It is better to do by the basics without going for the short methods, even for the short question. That is better. Right. Next, so that the point P lies outside is next. So you have to find here PC length. Why we find PC length? If PC length is greater than the radius, it is outside. On the circumference, it is going to be equal to the radius. Less than the radius, it is inside of the circle. Here PC, you know, P is given to be 4 to only. So 4 minus 2 x coordinate difference plus 4 to 2 minus 1 squared square root units. So PC is going to be 2 squared 4 1 root 5 units. Root 5 units which is greater than radius. Therefore, P lies outside. P lies outside. Right. The next part. Find the length of the tangents from P to S. It should be P to S. Find the length of the tangents. So as we have proven that P is outside, which is 4 2. It is a short question. You can directly use the formula. So length of the tangents, you know that both the lengths are the same. Let the length be L. You can directly say here L is how to find the length. You have to directly substitute the coordinates for the circle. So it is going to be 4 squared. So just remind the formula. Once the point outside is x naught, y naught, and the circle generally is given to be S is x squared plus y squared plus 2gx plus 2fy plus z0. So you have to replace x's and y's respectively by x naught and y naught. Then x naught squared plus y naught squared plus 2gx naught plus 2fy naught plus c equals 0 in that way, right? So here 4 squared plus 2 squared minus 4 into 4 minus 2 into 2 plus 4 units is going to be the length. So L is 4 square minus 4 square, 2 square minus 2 square, root 4, even you don't need the root here, 2 units. So you have two tangents which are equally length, which is 2 units. Clear? So that is it for question number 4. You can complete. Then we will move to the calculus question, which is question number 5. All right. Yeah, you can use the Pythagoras as well, since they haven't told you hence or any part. So the formula is okay as well, or you can use the Pythagoras as well. Had it been hence, yeah, you would have used Pythagoras because you know PC and the radius as well right away. That is what we used in proving this, right? So in case you have essay part, you must do that. You can't use the formula. Good question. Question number 5. All the way up to question number 4. Now question number 5. Question number 5. Find the derivative of x square dx dx. Ne? X square dx dx. So it is a product. Keep x squared differentiate dx plus epx differentiate x squared. So it is going to be x squared dx plus this is 2x, maybe 2x dx. Right. You can even take x's out, so it's just okay for the final answer. Or even you can take xex out, and you will have x plus 2. X squared dx plus 2x dx. Done. The next. Now we have to find the integral of x squared plus 2 x cubed dx squared. All right. So let the integral be x cubed x squared plus 2 e to the power x dx. By the way, by looking at this, we can see that you cannot directly derive, as you have shown, the derivative of x squared dx is x plus 2. If we can see, find the integral of right away x into x plus 2. Yeah, we would say it is right away x squared dx, but you can't see the same. But you can match this accordingly. By the way, this is going to be x squared. How to match? The matching means it is like all the x's has been replaced by x squared. You know that in such an integral, you can't say, x is replaced by x squared, so we are going to replace. No, that is for that variable conversion. You know that you have that integrating variable as well. You have to change those things accordingly and continue. Therefore, you need to substitute. So the substitution, x equals x squared, but you know that you can't substitute between the same variable. So x equals, let us say, t square. By substituting, x equals t squared, I is going to be before to I, we'll change the things. In particular, you don't have limits, so the integrating variable x equals t squared, and at the same time differentiating with respect to t. So it is going to be dx by dt equals 2t. All right. So now, what about I? I is going to be x cube. By the way, wait. X equals t squared. Here it is not x equals t squared. Why I say that? Had it been started from here, you would have used x equals t squared. By the way, you are going to integrate this. So x squared Understand that well. We have to do that accordingly. So x square should be replaced by x to have this. Then we can write down the answer. Or else you have to start from this. You have to say, integral of this is that, and do accordingly. By the way, as I've started from here, you have to use x squared equals this x squared equals x squared is c. Differentiating with respect to x, it is going to be yes 2x equals 2x equals dt by dx. 2x equals dt by dx. Then what about I? You have to have x cube, which is x squared into x. X squared is t. X squared plus 2 is going to be t plus 2. Dx squared is going to be e to the power t. Dx is going to be dt over 2. Dx is going to be dt over 2x. By the way, we need to make sure that the two sides, I mean, when you have this dt by dx, in replacing, you cannot mix up between the variables. That is why. So what about x dx eventually? X squared has been used. This is okay. This is okay. X dx is, yeah, dt by 2. That is going to be dt by 2. You can multiply these 2 here to balance. So it is going to be 2y equals t, t plus 2, dt dt. Is that clear? Now you can match t plus 2 et dt, x plus 2 ex dx, x plus 2 x plus 2 ex dx is this. So now it is about replacing by replacing variable, because the variable doesn't matter for the answer of the integral. It is the same thing. You can say 2y equals x plus 2 ex dx. So 2y equals x squared dx plus c1. I equals x squared dx by 2 plus c2. That is the final answer. X squared dx by 2 plus c2. Here you have to say c1, c2 are arbitrary constants. c1, c2 are arbitrary constants. Clear? That is the way. You can even follow starting from here, saying that x equals t squared as well. Right? It's a good question, even though it is like seems a little question, but a good question. Yeah, you can revise your substitution skills again. Right? Okay, complete then. Let's go for the next. All right. So did you try by using the other method as well? I hope so. Let us go for question number 6. Up to question number 5 done. Question number 6. In question number 6, what they say, a balloon carrying a small uniform ball start from rest from a point on the ground at time t equals 0 and moves vertically upwards with uniform acceleration F, where F is less than G. Uh, at time t equals T, the ball gets gently detached from balloon and moves under gravity. Sketch the VT graph for the upward motion of the ball from t equals 0 until the ball reaches its maximum height. Find the maximum height reached by the ball in terms of TF and G. Correct. So it is about the ball velocity. Have they given any units? No, nothing. And time. As far as the ball is attached with the balloon, it is like this. After they say sketch VT graph for the upward motion of the ball from t equals 0 until the ball reaches its maximum height. So as I say, this is enough. So we name this as theta and this as beta. You can see here tan theta is f, tan beta is so this is the triangle is to be based on the triangles to find out the value. By the way, this is capital T. Let us consider it as symbol. We don't know about this velocity. Let us bring that v. So you can see considering gradient, considering gradients, tan theta is going to be v over t. If p is going to be v over t, v is going to be ft. Now further, tan beta is going to be v over t. What about tan beta? It is g, v over t. Further, you know v, so t is v over g. T is v over g. Therefore, that time is needed. By the way, find the maximum height reached by the ball in terms of. So you have to find the maximum height. By the way, what is the maximum height? It is going to be the total displacement. That is going to be the maximum height for the ball, right? So by the way, before that, what is t? Oh, we later substitute t. You know t now. You know t now. Capital T is the data. Oh, by the way, what is t? You substitute it by now, then later we simplify. P is ft, so it is ft over g. Now you can say now maximum height equal sum of the areas of the triangle. So it is going to be v into t plus t. Half into v into t plus t. So half into what about v? ft. ft into t plus t. T plus t. So t plus ft over g. So finally it is going to be half ft square. Oh, totally ft square over 2g into g plus f or f plus g. That is going to be the final answer. Okay. ft, again t out, ft squared by 2g, g plus f or f plus g or g. So that is going to be the final answer. Hope you completed. You have completed. Otherwise, you can do the corrections by now. Right. So normally, you will be given for a short question VT graph for projectile. By the way, it is like in the trend of the new syllabus, you know that 11A is VT graph. In some of the years, they have given projectiles as well, but the normal trend is VT graph. So please complete. All right. So question number 7. Question number 7. Question number 7. What I've given to you. A smooth wedge of mass capital M rests on a smooth horizontal table. Initially, a particle of mass M is gently placed on its face, inclined an angle beta to the horizontal, so that when the particle has acquired a velocity v relative to wedge, the velocity of the wedge is the velocity of the wedge is. So you might think, why such a question? You know, this question type, it is relative acceleration. Normally, what you have to do is you have to find the accelerations. You have to calculate for the relative accelerations. Because in applied F equals ma, you need the acceleration relative to the Earth, which is considered to be the initial frame, and yeah, you have to do so much of work. By the way, here what we are doing is different thing. Again, a smooth wedge of mass capital M rests on a smooth horizontal table. Initially, a particle of mass simple M is gently placed on its face, inclined at angle beta to the horizontal, so that when the particle has acquired a velocity v relative to the wedge, the velocity of the wedge is. All right, this is what I'm going to do. So this is going to be the start. This is going to be the start. So that is at t equals 0, let us say. This is the start. Time equals 0, no velocity. You just gently place that. So after a general time, so let us say time equals t. It has got a velocity v as they say. Right, that is the velocity of the particle relative to weight. Right. So let us say velocity of weight relative to Earth at that time is u. All right. So this is particle mass M. This is weight mass capital A. Mass is capital A. By the way, something is here. When you consider the particle for the direction of motion, particle has got a force due that direction. What is the force? Reaction from the wedge to the particle. Wedge also has got a force. It is that right away the opposite one, the reaction from the particle on the wedge. By the way, when you consider about the system, you don't have any force due to the direction of the motion. Thereby, linear momentum is conserved. That is a fact. So you don't need to find anything apart from applying momentum of conservation of linear momentum. You can say applying, or you know that normally when we apply linear momentum conservation, it is not the law we apply, but I equals delta mv. So let us apply that, but before that, you need to have the velocity of particle relative to the Earth. You can say by relative velocity theorem, velocity of particle to Earth is velocity of particle to wedge plus velocity of wedge to Earth. Velocity of particle to Earth is particle to wedge. So what is the angle? Beta. So it is going to be B beta plus U. So VP is, you can just keep it like this because you whenever you need it you can resolve. Now you can start after that applying I equals delta mv towards right for system. So no I is there, so it is 0, 0 equals afterwards it is mu plus simple m into u minus v cos beta. That is yeah, after the certain time, because for any time linear momentum is conserved. But before that means at the start, so let us see, we don't have anything. So there you can see it is going to be 0, nothing. No linear momentum since both has got no velocity at the start. Right. So 0 equals, let us make u's together and v's together. mv cos beta. Therefore, what you need is what you have been asked, the velocity of the wavelength. So it is going to be mv cos beta over m plus a. That is mv cos beta over m plus a. Clear? That is what you have to practice, like all the question model before going to the exam. Otherwise, you might say after the exam, yeah, we had such a hard question with relative acceleration. I had to calculate that acceleration and this acceleration. And finally, I ended up being like, I didn't have enough time to do the other questions. That is your mistake because you haven't practiced well. That is why, right? Do the corrections. All right. Next question. Question number 8. Question number 8. Question number 8. In question number 8, the position vectors of A and B with reference to the point O are respectively. So write down those data. OA is OI plus 3J, right? And what about OB? OB is I plus J. That is I plus J. I unit vectors alone, OX and OY axis. Find the angle AOB. Find the angle AOB. So you know that it is like this name. O is here. OA and OB. Let the angle be between, angle AOB. You can see let angle AOB is, you don't need to specify that including angle because it is already OAO. Correct? So what you need to do to find this angle is obviously whatever related to angle usually is dot product. You can see here OA dot OB is OA magnitude, OB magnitude cos theta. What about OA? OI plus 3J dot I plus J equal OA magnitude square root of 4 square plus 3 square into OB magnitude square root of 1 square plus into cos theta. Right. It is O into I dot I plus 3 into J dot J equals 5 root 2 cos theta. So this is 1, this is also 1. 4 plus 3, 7. So cos theta is going to be 7 over 5 root 2. Find the angle AOB. It is better to rationalize 7 root 10 over, sorry, 7 root 2 over 10. Therefore, you can say theta, which is the AOB angle, is cos inverse 7 root 2 over. That is the answer for the first part. The second, if the position vector of C, so that OC is perpendicular to AB. So that OC is perpendicular to AB. By the way, further you can see, is you know OC, to show that OC is perpendicular to AB, you need to know AB vector. You can say by triangle after that, right? After this. By triangle of vector addition, because you don't know AB. By triangle of vector addition, what about AB? That is AO plus OB. What about AB, by the way? AO minus 4I minus 3J plus I plus J. AB is minus 4I plus I minus 3I minus 3J plus J minus 2J minus 3I minus 2J. That is AB. Now let us again do the dot product of AB and OC, because you know you need to show that they are perpendicular. I'll check your question. So I want to use dot product to say that OC and AB are perpendicular. Yeah, that is what I'm going to do. By the way, before that you need AB. Now after this, you can see again further OC dot AB is going to be, what is OC as they have given? 2I minus 3J. 2I minus 3J plus AB is minus 3I plus minus 3I minus 2G. They are minus 6 I dot I, I dot j and j dot I are 0, plus 6 I dot j. So that is going to be 0. Therefore you can see OC is perpendicular to G. That is it for the answer. Okay? Please ask if you have any doubt. All right. The next question. Question number 9. There you have, yeah, you must have completed this because we did a similar question in last week where we were new a rhombus. Here, the square. I think here it is comparatively easier than the last week's question. Question number 9. What they say, ABCD is a square. Four particles of mass n each are kept at rest at the four vertices of the square and are connected by four light inextensible strings A, B, B, C, C, D, and D. All the strings are towed. If an impulse I is given to particle A in the direction CA, find the initial velocity of the motion of each particle. Right, so it is a square. You have four particles at the edges or at the vertices. A, B, C, D. Along AC direction, those are 90 pi by 4. All right. So what is special here? You don't need to give go for V1 and V2. In last week, as it was a rhombus, we have to go for V1 and V2. Here it is symmetrical. You can see it is V. So let us say the horizontal, just after the impulse, the horizontal component of the A is V. So it is as same as the vertical component. So it continues for here and for here. You know that no influence from either strings. From either strings. After this, you know that the same, I mean, impulses happen. They are also the same. Course, it is symmetrical. So let us say it is I1. So this is also I1. In last week, we had to mark two velocities and two impulses. Then after the four equations only, we got the final answers here. Yeah, you have only two unknowns, which are V and I1. So let us apply. For B, we are applying I equals delta NV. So that is going to be I1 equals M into V1. For D, you are applying I equals delta NV. There I1 equals M V. It is no point of applying because of the symmetry you already have decided there. Now you know I1 by the way. Let us go for directly A. For A, you can apply I equals delta NV for any direction you prefer. I'm applying towards here. So it is I cos 45 minus I1 equals M V minus nothing. Right? V minus nothing. At start, you don't have anything. Even you can say just V without minus. So, yeah, let us mark this as 2. After labeling this as over 2. So, by 1 and 2, you can say I over root 2 minus MV is MV. So, 2 of me is 1 over I over root 2. Further, let us rationalize root 2 I over 2 is 2 MV. So what you have to find is V, the velocities, velocities of the motion of each particle. V is going to be root 2 I over 4a. Now we can finalize the velocities. Therefore, velocity, they ask velocity, not the speed. Had it been the speed is the same, the magnitude of velocity. By the way, if they ask the velocity, you have to mention the directions as well. Velocity of, so the velocity of A. Velocity of A equals velocity of A equals it is V and V root 2 root 2. So it is going to be root 2 V 45 angle root 2 V. So it is going to be I over 2A. Then velocity of V towards up it is V root 2 I over 4A. Velocity of V is V root 2 I over 4A. So those are the answers where you don't have any velocity for C. You don't have any velocity for C. Clear? Yeah, when we apply for A, you can apply for any of the directions. As far as you, whatever the unknown, you can involve that here. So I apply towards horizontal. You can either apply towards vertical or inclined. So after applying towards horizontal, the productive or let us say the effective I is I cos 45 minus I1 equals towards the direction. That is just MD. Yeah. That is how after I found I1, I substituted directly, right? So please complete. You can, I mean, I think you already have completed this. In case you got the question for the last week properly, you understood that properly, this could have been easier for you. If not, that is why. Once you are given the question, you have to learn from that. Then you can answer the next question properly. Otherwise, the same thing continues and you won't answer any of the questions properly. Never. Okay. So please complete. All right. It's number 10. The last short question. As I've told you repeatedly, yes, if you need an A, you have to complete these 10 short questions within the given 40 minutes. They are only in that point. You can target forward for any. Otherwise, you know that the reality is, yeah, you cannot have any. That is why I keep saying you do the hard work. You have to do the hard work. You have to think nothing is impossible. Yes, some some of the things are not going well with me. By the way, if I do more hard work, I can even achieve that impossible. Right? That is what you need to do. So that thing is certain. When is the day? You don't have much of the days. When is the day you complete all the 10 questions within the 40 minutes properly, correctly? Then you are like, yeah, you will have A with keeping that hard work forward, right? Question number 10. Question number 10. A sphere of radius A and weight W rests on a smooth plane inclined at an angle beta with the horizontal. Right. It is supported by a string of length L with one end attached to a point on the surface of the sphere and the other end fastened to a point on the plane. Sketching the free body diagram, marking all the forces, determine the tension of the string. Right. So this is the inclined plane. Let this be the sphere. You know that work is acting from the center for the sphere. So that is the weight. They have given the weight in it, W. And the perpendicular reaction is acting perpendicularly, obviously, R. And it is beta and minus beta, and it is also beta. Then where that string is attached, you know that under three forces, that special case, a rigid body to be in equilibrium, the three forces should be concurrent in the free body diagram. So this is where the string is attached accordingly. You can mark the this is point of concurrence, by the way. So the radius is given to be A. Have they given the length of the string? Yeah, the length is L here. So the issue is the angle you don't know here. You cannot relate that with beta because of connection is there, right? So by the way, you can specify that angle separately as theta for a right angle triangle where the opposite side for theta is A and the hypotenuse as L plus A. This is A, this is L plus A. By Pythagoras, let us find out this particular length, naming that as, so let us say B by Pythagoras theorem. E is going to be square root of L plus A square minus A square. D is going to be L square plus 2LA. L square plus 2LA. 2LA, that is E. Right. So, what you can do here is you have to find the tension. So, you know that once a rigid body is in equilibrium under system of forces, so let us say in general, resultant is zero. So, two components which are perpendicular to each other is always zero, and moment around any point is zero. So, I prefer to have, normally when we have inclined plane, we normally do not resolve alone x and y, I mean, other than for the special occasions, we resolve alone the inclined plane and perpendicular to the inclined plane. Here in particular, since we are asked to find the tension, so let us resolve through the inclined plane. So you can say by resolving forces, yeah, along the inclined plane is going to be zero since it's in equilibrium. You don't need to mention that again. because it is mentioned in the answer, the question. So there, this is theta 90, and this is 90 minus theta. This t is acting upon the sphere. This t is acting upon the inclined plane. So 90 minus theta. T sine 90 minus theta. T sine 90 minus theta minus W sine beta. Minus W sine beta is 0. So T cos theta is W sine beta. T equals W sine beta over, what is cos theta? B over L plus A. So square root of L into L plus 2A over L plus A. Therefore, what about T? W into L plus A sin beta over square root of L into L plus 2A. That is the answer for the tension. Determine the tension of the string. They haven't given any unit now, so that is it for the tension. Those who have got this within the given time, I can't remember in the class. No one got, I think. After the class, will you try again those who have got this? By the way, good. Please complete. All right, so we'll start essays. The question number one. Yeah, from a time we didn't discuss that question number one, which is algebra question. By the way, today we are going to discuss it. 11A. 11A. But they say if roots of the equation A, C are not zero, usually A is not zero, but they have given C is not zero for reason. Let's see. And the ratio lambda to 1. Prove that. All right. So you can mention let the roots of x squared plus bx plus equals 0, x squared plus bx plus equals 0, where AC are not 0, b lambda to 1 in the ratio. So you can see lambda alpha and alpha, lambda to 1. And you right away have to say alpha is not 0. If alpha is 0, the two roots are 0, 0. Not lambda to 1. Alpha is not 0. It doesn't matter plus or minus. Prove that. So you have to prove this given equation. Now that is, by the way, that is the reason. They have given that AC both are not 0 because for the next quadratic equation, the leading coefficient is AC. That is why. By the way, what you can do here is you can derive the two relationships for the roots. Here it is not about delta x. You don't need to investigate on the nature of the roots. Since the roots are given, you have to go with the relationship. So you can see here, lambda alpha plus alpha is sum of the roots minus b over a. So alpha out, lambda plus 1 is minus b over a. 1. Then lambda alpha into alpha is c over a. So lambda alpha squared is c over a. Equation number 2. By 1 and 2, you can relate them by using alpha for both. Alpha is common, but in different ways. In one, you have alpha. In the second, you have alpha squared. So you can see by 1 and 2, here it is alpha. So minus b over lambda plus 1 into a. That is alpha. So alpha squared is here, right away alpha squared. B over lambda a. Beta square. B squared over lambda plus 1 squared into a square is c over lambda a. You can cancel out 1 a because a is not 0. This is where you have to lead. You have to lead for a for the quadratic equation of lambda. Let us cross multiply uh, AC into lambda plus 1 squared equals b squared lambda. So AC lambda squared plus 2AC lambda plus AC is b squared lambda. So AC lambda squared plus 2AC minus b squared lambda plus AC is 0. That is it for the quadratic. AC lambda square plus 2AC minus b square lambda plus AC is 0. Right. So that is the first part. In case you haven't completed, please complete the first part. Then we'll continue accordingly. All okay. So the next part, if ratio between the roots of the equations x squared plus mx plus n0 and the ratio between the roots of the equation ex squared plus qx plus r equals 0 are equal, deduce that. If those ratios are equal. All right. So if those ratios are equal, you have to deduce. From where we can start? In deducing part, we have to grab something from here. By the way, it is about lambda. Here we have lambda. Let's see. So this A. We'll start with this. Same ratios we both have. We see a common ratio. Let mu to 1. Let mu to 1 be the ratio. Let mu to 1 be the ratio. Mu to 1. Then when mu to 1 is the ratio, you can say then squared mx plus ex squared qx plus r. It should be lx squared plus mx plus a. L is missed there. So, I mean, accordingly, right? Because you have proven the things. So, it is going to be ln mu squared plus 2 ln minus m squared mu plus ln equals 0. The first one. And for the second quadratic equation, it is going to be accordingly px squared plus qx plus r er plus 2pr minus q squared mu plus er is 0. By these two, you have to go for yeah to the relationship. By the way, as mu is the same, what you can do here is think something is missing here. By the way, we'll try. Because normally in this question, before to the deducing part, they normally have to give something regarding to lambda. It's all okay. Lambda is given and we just got the quadratic equation as well. By the way, from both the equations, the solutions we are going to have is mu. You can relate that. Yeah, we'll go accordingly. If we like get stuck, we'll think again. So here you can see here d squared minus 4ac. It is plus or minus b squared minus 4c square root upon 2. By the way, hard. I'm going to use the equation to find mu and get them equal. So here's we should have an easier method. Or something is like here missed already. So let's see. They have given the roots, the ratio to be lambda to 1. And we proved that the quadratic equation of lambda uh, the ratio between the roots of the equation are equal, deduce that are equal. All right, we can go with that without finding the roots directly. Since the roots are like equal, that is the same unit, we can say the ratio is the same. So you can compare. This is what you can do. Here they have given you. You don't even to name this equation. It is okay to name. But the thing is the mu is the same, and they have given L in both are not zero, and P are both are not zero. It's not like something is being missed, but we have to think further. So here they have given L in both are not zero, and here P are both are not zero. So here we can get everything divided by L in. So you have u squared plus 2 ln minus m squared over ln mu plus 1. Right? It is right away equal to 1. So get divided by that particular what we call the leading coefficient. The two quadratic equations should be the same. Why is that? Yeah, it is the same mu. It depends on the leading coefficient. So here u squared plus 2pr minus q squared over pr mu plus 1. So you can compare the coefficients of mu. Mu squared and constant is the same. Comparing coefficients of mu. Then 2 ln minus m squared over ln equals m squared over ln equals 2pr minus q squared over pr. Now what you need to do, you have to come up to here again, here until the relationship they have given. So let us first multiply 2 ln pr minus m squared pr equals 2pr ln minus q squared ln. So pr ln 2 ln pr. So let us multiply both the sides with minus m squared pr equals q squared ln. That is it. M squared pr equals q squared ln. The relationship you just proved. All clear? So I'll again describe from the beginning. They have given the ratio to be lambda to 1. So you prove that quadratic equation. Then they have given to deduce, giving two quadratic equations as the same ratio. So we got it as mu. By the way, we derived the two quadratic equations, and since mu is the same, you cannot have like different values. For the same mu, you have to have the same value. So for these two quadratic equations, you have to have the same roots. By the way, you can only equate the quadratic equations even though they have the same roots when the leading coefficient is the same. You focus on the leading coefficient. If the leading coefficient is the same under the same roots, then the quadratic polynomial, so the quadratic functions are the same. Then you can compare the coefficient. This is what we do. We have the practice on doing this, improving alpha plus beta and alpha beta. This is the same thing we do. So please complete, and then we'll go for part B. All right, part B for the same question, question number 11. So in part B, they say let A be a real number. Let A be real. And if fx equals, it is given that 3x minus 1 is a factor of fx. Find the value of x. So they have given fx to be 3x cubed plus 5x squared plus x minus 1 where a is real. Where a is real. So 3x minus 1 is a factor. So you can say by factor theorem, 3x minus 1 is the factor and 1 by 3 is 0. By factor theorem, 1 by 3 is 0. Is 3x minus 1 is a factor. So 3 into 1 by 3 cube plus 5 into 1 by 3 square plus a into 1 by 3 minus 1 is 0 multiplied by 3 cube. So 3, 50, 3 cube, 9 8, 27 is 0. 9 is going to be, this is 18, 9. A is 1. A is 1. So after A is 1, find the value of A done. Express fx in the form name. So you have to update fx first after this. After this, you have to update fx. So you can see now. After this, you can see now. What about fx? A is 1 and so this is plus 1 x, which is plus 6. Plus x minus 1. Done up to there. Right. Further, and the value of x plus fx in the form x minus 1 into x plus k square. By the way, you can say further fx, which is 3x cubed plus 5x square plus x minus 1 is 3x minus 1 already is a factor they have already given further as well. X plus k squared. So you can go with what they have given. No, you can define x squared plus bx plus c as well. By the way, let us go with what they have defined. X plus k squared. So x squared plus 2kx plus x squared. Here k is also a constant, a real constant. So we can expand accordingly to compare the coefficients to have k. That is going to be x cubed x squared plus to have x squared 2k into 3 6k minus 1 x squared x's plus 3k squared minus 2kx minus k squared minus k squared. So by comparing coefficients, let us compare the coefficient of x squared. 6k minus 1 is 5. So 6k is 6. K is 1. K is 1. You just have shown k. They don't need k. By the way, they need the format name. K is 1 is here, by the way. Therefore, you can say fx is 3x minus 1 into x plus 1 square. Where k is 1, you don't need to write down. In that way, x square plus bx plus c, you have to write down k. So can we use lone division? Yeah, because they haven't recommended anything. X plus fx in the form where k is a constant. Yeah, you can. Doesn't matter. Then, by writing 3x minus 1 in the above expression in the form, by writing next, so you don't need to do all the hard work. As far as by writing, you can see now 3x minus 1 is 3x minus 1 is uh, oh, b into x plus 2 plus c. So it is going to be b into x plus 2. By the way, it should be the coefficient of x should be 3x. So 3 into x plus 2. 3 into x plus 2 plus c. 3x is okay, plus 6 is okay, but by the way, you need minus 1. So it is minus 7. Where you can recommend b and c. B is 2 and c is minus 7. B is 2 and c is minus 7. Okay. B is 2 and c is minus 7. B into x plus 2 plus c. 3x minus 1. All okay. The b and c are constants. Find the remainder when fx is divided by. By the way, here you can't use lone division because it is that hidden word you have to read properly. By, then by writing 3x minus 1 in the above expression in the form where b and c are constants, find the remainder. It is a flow. So by writing down, you have to use this. You have to use this conversion to find out the remainder when fx is divided by x plus 2, x plus 1 square. Right. So try for it. Complete up to here. Do the correction. Then I'll come and complete. All right. So now how to derive? This is how you have to derive that. After that, you have to say further, right, by writing down 3x minus 1 in the above expression. So you have to change the mode of 3x minus 1 accordingly. So fx is 3x minus 1 is t into x plus 2 minus 7. T into x plus 2 minus 7. That is 3x minus 1 into x plus 1 square. So fx further is t into x plus 2 x plus 1 square minus 7 into x plus 1 square. Yeah, we just got something we have been searching for. Let's see how to relate that to the answer. They ask, find the remainder when fx is divided by x plus 2 x plus 1 square. Fx is divided by x plus 2 x plus 1 square. The quotient is 3 and the remainder is 6. That is division algorithm. So you can say by division algorithm, whatever by using what you observe, you have to mention. By division algorithm, x is divided by x plus 2 x plus 1 squared. The remainder is they don't need the quotient. The quotient is 3. By the way, the remainder is minus 17 to x plus 1 squared. That is the field. Clear? That is the remainder. All right. So that is it. By completing these, we will be there for the applied question 30. All right. So question number 13 part is projectiles. Projectiles. 13. Part A. A particle projected from a point O on horizontal ground with the velocity u, which is root 2 ga, making an angle beta, which is an acute to the horizontal, moves under gravity and hits a target at a point P. The horizontal and vertical distances of P measured from O are A and K respectively, where K is a constant. Show that and deduce that. Alright. Put it like this. For the projectile, so they say it hits. It hits. P A K A. So starting with the velocity u is root 2 inclined to the horizontal by beta q. So what you can do is this is O. O to P, you can apply the appropriate equations to have the equation of trajectory. Yeah, I think it is better to name. Oh, by the way, you can continue like this also. You can even define the coordinate planes and apply the things. By the way, I'll continue like this. From O to P, S equals ut for particle. For particle. Here, take the time as 0 as it is the start. Then for the final point, point 3, I'll take time as time is 0, 0, time as 6. The general that point particular at that is they have given a point. So for the particles, you can say S is A equal U is U cos beta into T. Equation number 1. Then S equals ut plus, this is how you have the equation of trajectory for particle. For particle. Then Ka is u sin beta T minus half G V square 2. By 1 to 2, you can substitute me. By 1 to 2, you substitute equals A over u cos beta. Then A equals u sin beta is what is T? A over u cos beta minus half G T squared is A squared over u squared cos squared beta. Further, u to u can be cancelled out. This A equals A tan beta minus dA squared minus dA squared over 2u squared cos squared beta. By the way, since we need the quadratic in terms of tan, I'll put the cos squared beta to the numerator and that is sec squared beta, the reciprocal of cos. Sec squared beta. And sec squared beta is 1 plus tan squared beta by trigonometry because I need tans. I need tans. Eventually, I need tan, right? Over for u squared, you have 2 as 2 into for u squared, what term is previously I kept as u because I could cancel out. Now you can put u as root 2g, so u squared is 2g. 2g, g to g, a to 1a. Right, so let us multiply everything by 4. 4k equals 4a and beta minus a into 1 plus tan square beta. You can now cancel out a. Now you need the quadratic of tan beta. So tan square beta minus 4 tan beta plus 1 plus 4k. So 4k plus 1 equals this will be the quadratic equation. Tan square beta minus 4 tan beta plus 4k plus 1 equals 0 is the equation. Now we have to deduce. Try for the deducing part after this. Please get for the corrections up to here and try for the reducing part. Well, okay. Then what to do? What about that condition? Yeah, k is less than or equals 3 by 4. This quadratic case of tan beta. So by that, what we can argue is the nature of the roots. If this has got two distinct roots, you can see to hit to that target, you have two betas to project with. So if you have delta x to be 0, two roots with equal value, there you have only one particular angle. If the discriminant is like negative, you cannot hit to that target. By the way, so since they have told you that, yeah, it has got the answers, it should be real. In particular, real. It cannot. It can be distinct or equal. We don't know. In particular, real. Here you have to argue that here delta tan beta should be greater than or equals for real beta for real tan beta eventually for real beta. So b squared minus 4a should be greater than or equal to 0. So this is going to be 16 minus 4 into 4k plus 1 greater than or equal to 0 divided by 4. So 4k plus 1 less than or equal 4 here. K is less than or equals 3 by 4. K is less than or equals 3 by 4. Right. Now let K, this is. So follow K. I'll leave this part since I completed. Right. Next. What they say, now let K equals 11 over 16. Yeah, it is less than 3 over 4. Okay. So real roots, you have real betas. So that the angle between the two possible directions of projection is right. K is 11 by 16 and we have to update this by the way. Now, what about that tan squared beta minus 4 tan beta plus 4k plus 1. 4. What is k? K is 11 by 16. 11 by 16 plus 1 equals 0. So tan squared beta minus 4 tan beta minus 4 tan beta plus 15 over 4 is 0. That is the quadratic of tan beta. That is the quadratic of tan beta. Right. So they have recommended that two possible directions. So let me introduce the two beta. So let me say let the roots be tan beta 1 and tan beta 2. Then you know it is now pure maths. Moving to pure maths. Now you know since they have recommended the two directions, so we have two angles. That is why I have named after beta 1 and beta 2. In particular, quadratic case of tan beta. So that is why I mentioned without mentioning beta 1 and beta 2, tan beta 1 and tan beta 2. So sum of the roots, then sum of the roots, tan beta 1 plus tan beta 2 is minus b over a. Product of the roots, tan beta 1, tan beta 2, c over a is going to be 15 over 4. Right. What they ask, um, angle between the two possible directions. So it should be tan angle between. You don't know in between these two, beta 1 and beta 2. Yeah, tan is increasing function, by the way, which is larger. So you have to use modulus. Tan beta 1 minus beta 2 equals modulus of tan beta 1 minus tan beta 2 over 1 plus tan beta 1 tan beta 2. Right? So what is going to be tan beta 1 minus beta 2 modulus? And beta 1 minus tan beta 2 is going to be square root of plus square root of tan beta 1 plus tan beta 2 square minus 4 tan beta 1 tan beta 2 over 1 plus tan beta 1 tan beta 2 1 plus 15 over 4. You don't need the modulus as it is plus. So 1 plus 15 over 4, 19 over 4. Further, tan beta 1 plus tan beta 2 square. 16 minus 4 into this. So it is 16 minus 15 over 4 into 4. 1. So eventually it is 9 over 4 over 19. It is tan beta 1 minus beta 2. Now you can finalize. Therefore, angle between beta 1 minus beta 2 modulus is tan inverse 4 upon 90. Tan inverse 4 upon 90. That is going to be the final answer. Is that clear? Right. So please do your corrections. If you have any further issue, please ask. All right. Part B, relative velocity. Relative velocity. So we have a question. Beta should be real. Otherwise, what if beta is not real? You cannot have such a motion. The angle should be real for a motion. As far as you got a quadratic, had it been a linear equation, for sure beta is real. But once you have a quadratic, you have to further justify that variable low, that particular unknown, whatever regarding the angle in particular is real. Otherwise, the motion is not possible if it is not real. That is right. So part B, relative velocity. Relative velocity question. A river with straight parallel banks and breadth A flows at an uniform speed. There the uniform speed is missed the yes, uniform speed U it should be U, right? A and B are 2 points on opposite banks such that the point B is below the point A. The line AB makes an angle alpha with the river banks. All right. We have to have a sketching here. It is below B. It doesn't matter actually because they haven't mentioned upstream or the downstream, the alpha, so it doesn't matter. You can mark any angle alpha. Right. They are breadth A. So here it is about A. Two boards X and Y move with the velocities V and U. B is below the point A. Ne? So let us mark this as B, as they say. B is below the point A. Right. Two boards X and Y move with velocities V and W, where VW both are greater than U. In still water moves along the line AB is starting from the point A and B respectively. From point A, who starts? X. From point A, X starts. From point B, Y starts. What about velocity of X with relative to Earth is V. Velocity of Y with relative to Earth is W. Before everything, let us mark U as the velocity of water with relative to Earth. As marking the water. Doesn't matter if you mark in the other direction. Right. Draw velocity triangles for the journey of X and Y and show that the time taken for the two boards to meet each other. By the way, these paths are relative to the Earth. So you can find the intersection of the two boards once you find velocity relative to Earth only. Here you have velocity relative to yeah. That is the mistake I've done. Now let us correct that properly. They have given two boards X and Y moving with velocities in still water. Strictly no. Strictly not allowed. It's relative to water. So when I started this lesson, I repeatedly told you that they give. Normally when the frame is water, it's still water. It's like, for example, once as far as a person is considered, the velocity he can swim in a swimming pool. So in still water. By the way, that is his ability. The velocity he is able to swim. no matter where he goes, so we consider the constant velocity theoretically, he swims with the same velocity. The same thing is here. Still water is the ability, the able speed of the boat where it can move in with, right? It can be moving with. There, yeah. So these are the velocities relative to water respectively for the two boats. You have to find the velocities relative to the earth. Then only you can find the intersection, because this part, it is relative to the earth. This is from the earth, from the frame of the earth, what you observe. Because even though the water is flowing, these positions are relative to earth. They are not anymore. They are constant. Let us consider relative velocity here. Let us consider relative velocity. Considering relative velocity theorem, velocity of x relative to earth is velocity of x to water plus velocity of water to earth. So velocity of x to earth is x to water v plus water to earth. By the way, you can give velocity of x to e with the direction, because it starts from here. So this should be yeah alpha. Let us say that is r1. Let us say that is r1. Let us name it after r1. Then v y to earth is v y water plus v water earth. Then v y earth is v y to water is w. Here we have an issue. The issue is w is already given. Then actually this is simple w. This should be capital W relative to water. So if you are like, I might mix up between them, you have to go for water for some other letter. It doesn't matter, like T or something. So y is W plus again U. There you can, yes, name this Vy relative to earth as in this way. In this way. So it is going to be R. Let us mark it as R2. Alright. So you have to find R1 and R2 by triangle law of fit and by triangle law of fit addition, we are going to find. So it is going to be U first. Everything is greater than U. Everything is like V and W both are greater than U. Right? So U plus first V and then W. In the same line, so you can draw both the diagrams, sketch both the diagrams in the same. In the same diagram, you can sketch both the triangles. So U plus V is going to be this. U plus V, one after the other, is going to be this. For that, it is better to use a circle. Because when you go for V, U plus V, you are searching for V. You are searching for V, and it is better for you to use a circle with radius V. Because whatever the direction is, you have to go with that V. As the circle is the locus of that varying point, which is equidistant to a fixed point. So V is somewhere else in this circumference. By the way, now we have to decide something different. We cannot go for both the triangles in the same diagram, as the radii are different. Normally they give to be the same radii for certain applications, but here it is not. Here we end up with two different. So it is going to be R1. 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 So obviously, what about V? This is R1. What about V? V is V. U plus V is R1. What about R1? It is alpha. This angle is alpha. This is R1. The angle is alpha. This is R1. Right. They are. What we can further do, you have to find R1 by the way. Before going to the next diagram, you can complete the next diagram. I'll give you the time. I'll teach you how to find R1 from here. You have to go for this perpendicular. You can target Pythagoras theorem. And to target the Pythagoras theorem, you have to have right angle triangle. There, if this is alpha, this is also alpha. You can see this is u sine alpha, and this is the part is u cos alpha. Now it is possible to apply the Pythagoras theorem. Ne? The Pythagoras theorem. There, we apply the Pythagoras theorem for this triangle. It should be this by Pythagoras theorem. What should be R1 plus u plus alpha? It should be the square root of R1 plus u plus alpha is b square minus u square sine square alpha. B square minus u square sine square alpha positive root because we expect for the plus answer. Therefore, what about R1? Square root of b square minus u square sine square alpha minus u cos alpha. So you just found R1. You just found R1 by constructing the relevant perpendiculars, right? Now you know that we cannot stick with the same diagram for the other triangle. Go for the other triangle and please give me the answer of R2. Give me the answer of R2. Then we'll find accordingly the time taken to for two boats to meet each other, right? Complete. All right. So how to find R2? Let's find R2 by here. And this. Yeah. Further, W plus U. So U plus W again. The circle U to locate the correct W, the direction of W. By the way, there R is here, U plus W is R alpha. R2 with alpha. So this should be W. Alright. So where you need that the perpendicular is from here. To apply the Pythagoras, you have to search for the right angle triangle. There you can see this particular side is u sine alpha, and here is u cos alpha. You would have to further see further the value equals how. This is how. R2 minus u cos alpha is by Pythagoras theorem. By Pythagoras theorem. It's better if you can name the angles further. R2 minus u cos alpha, Pythagoras theorem to this triangle, square root of w square minus u square sine square alpha. Then R2 is u cos alpha plus the square root of w square minus u square sine square alpha. That is R2. Now R1 and R2 are done. So R1 direction and R2 direction are opposite as well. By the way, now you can find the time x and y and show that the time taken for the two boats to meet each other. Again, we need the relative velocity because both are moving. Still, I mean, by now we know the real velocity. The velocity is relative to Earth for both the boats. By the way, to find the time for the intersection, you need further the relative velocity. So there is this. I don't have space. You can say considering either way. So I'll consider any way you can consider. Considering velocity of x to y. So velocity of x to y according to relative velocity theorem is x to e plus e to y. By the way, what about x to y? X to e is down and this is up. This is down, which is alpha r1 and this is up. Alpha, this is r2. So by the way, what about x to y? You can consider either ways. X to y can be any way. By the way, we cannot decide that the directions we'll see. You should add me. Yeah. Anyway, it should be dxy should be x to y should be either r1 minus r2 or sorry, I have done a mistake. What is that? This is y to the earth. So earth to y is either in the other side. So you don't have that issue. Otherwise, it is a clash there. We had a contradiction. Now we don't have anything. It is angling alpha, which is r1 plus r2. Addition of these two, so u cos alpha gets cancelled out. We remain no clashes. Then what you can do is yes. What you can do is let us applying s equals ut relative velocity of x relative to y. So you consider theoretically y is at rest, you come there, right? Is equal to due this direction for relative motion in your state of certain for relative motion. And it being for the real motion, you don't need to mention it. Right? What about S? It is going to be this is A. Let us say this is L. L sin alpha is A. L is A cosec alpha. Or A was sin alpha, A cosec alpha. So S is A cosec alpha is U T. U T. What about U? It is R1 plus R2. 2 cos alpha gets cancelled out. Then square root of V squared minus U squared sin squared alpha plus square root of W squared minus U squared sin squared alpha into time t. So what about the time? Therefore, time is A cosec alpha over V squared minus U squared sin squared alpha plus square root of W squared minus U squared sin squared alpha. That is the time. No units are given. Find the distance to the intersection from point A. Intersection point from the point A. So you have to apply S equals ut for the real motion of x. Then you can find the distance. Okay. By naming the distance, you can finalize. And you know t now. To find t, it doesn't matter the relative motion or the absolute motion, the real motion. T is common. By the way, after finding t, you can even go for the relative motion or the real motion. Now you have to apply this t is equals to t for the real motion for x. Then you can find the distance from it. Complete and find that too. All right. So in finding the time, you just need to apply f equals ut for x, right? So line apply s equals ut line s equals ut direction for x. Then let's say if is L, U is R1 for x, ne? We named R1 is for x. Yeah, R1. R1 is this. Is going to be square root of b squared minus u squared sin squared alpha minus u cos alpha into t. A cosec alpha, b cosec alpha, totally over this. B squared minus u squared sin squared alpha root plus w squared minus u squared sin squared alpha root. That is it. That is it. Right? Well, okay. We'll move to trigonometric equation. Back to pure maths. Back to pure maths. Yeah. Let us start from part 1. What we have to do in part A, we have to solve equations. They find general solutions in particular. Question number 12, part A. Question number 12, part A. And again, part 1. 2 sin x minus cos x. 2 sin x minus cos x into 1 plus cos x. Into 1 plus cos x equals sin square x. Equals sin square x. By the way, you know that you in solving equations you have to factorize as much as possible to have an answer. So 2 sin x minus cos x into 1 plus cos x sin square is 1 minus cos square. I can see factors. So 2 sin x minus cos x 1 plus cos x will bring this to the same side. Then it is easier. I mean, we also have to keep 0 at one side to solve equation normally. So 1 minus cos squared x roots are minus is when you bring that to the other side. 1 minus cos x, 1 plus cos x is 0. Now you can take 1 plus cos x out as a common factor, then 2 sin x minus cos x, 2 sin x minus cos x, 2 sin x minus cos x, uh, minus 1 plus cos x 0. Cos x to cos x, 1 plus cos x 0 or 2 sin x minus 1 0. There cos x equals minus 1 no, sin x equals 1. I'll revise that when you have to go for the primary solution. So sine and tan, cosine and tan, we have the same convention. Primary solution lies in the first quadrant if it is plus, fourth quadrant if it is minus. Primary solution is also known to be the closest solution. When you go for cos, it is a different convention. By the way, for the plus the same, first quadrant the closest thing. By the way, for the minus, it is the second quadrant. Right. So to have sin x, these are to have sin x, it is sin x equals sin. Primary solution for half plus it is 30. Sin 5 by 6. So it is n 5 plus minus 1 to the power n 5 by 6. N is any integer, that is it. And cos 6 equals minus 1. So cos 6 equals cos. Regarding plus 1, the angle is 0. For the second quadrant, it is 5 minus. You always have to go for 5 minus for the cos. For sine and tan, in case that is negative, you have to go for the Write away the negative angle. For example, had it been minus half, you would have put minus 5 by 6. Clear? So 5 minus 0. So x is going to be, this is 5 right away. 2m5 plus or minus 5. And we see. So please finalize. Please do the corrections. Follow me. You can't, because you have to equate it to 0 to argue this point. I mean, at one point, why you factorize the expression regarding to equation to finalize that expression as a product. Then only you can argue when, and I mean, by finalizing the expression as a product, and at the same time, only if the other side is 0, then only you can argue that this 0 or that 0. That is why you have to have 0. You must have 0. Otherwise, for like when you have x squared is 1, x is plus or minus 1. For that special locations, it is okay to not to put 0. But usually, normally you have to have 0 to have products. Right. Part 2, we are going to do. What is the equation? 2 tan x plus sec 2x. 2 tan x plus sec 2x is 2 tan 2x. 2 tan x plus sec 2x, 2 tan 2x, right? You have to have a decision at the start whether you continue with tan or change this into sin and cos. If we continue with tan, you have to convert this tan, and for sec 2x, is going to be 1 over cos 2x. Yeah, the tan is like complicated here. How it's here. So let us put sin and cos. 2 sin x over cos x plus 1 over cos 2x equals 2 sin 2x over cos 2x. By the way, here cos 2x into cos x is the LCM. So 2 sin x cos 2x plus cos x is going to be cos 2x is here 2 sin 2x. 2 sin 2. All right. Now what you can do, you have to first multiply. Before to that, sin x over cos 6 tan x. By the way, without deciding any further things, let us cross multiply right away. So you have 2 sin x cos square 2x plus cos 6 cos 2x equals 2 sin 2x cos 2x cos 6. There, what we can do further is 2 sin x cos square 2x is here. Let us bring that to this side by taking cos 2x cos 6 as common. No point for now. No point for now. So we'll continue like this. Cos 6 cos 2x minus sin 2x is 2 sin x cos 6. So cos 2x sin x cos square x. Cos square x is 0. So what you can do is now you can take cos 2x out. After taking cos 2x out, it is 2 sin x cos 2x plus cos 6 minus 4 sin x cos square x is 0. Now we are all okay with cos 2x being 0. Now we read to that product. We are expecting that product to solve equation. Now I'm all okay with cos 2x. By the way, 2 sin x, I cannot convert the sines to cos. By the way, I have to think of converting those squares to sine. In that point, 2 sin x, this has 1 minus 2 sin squared x plus cos 6 minus 4 sin x into 1 minus sin squared x is 0. So you have plus 4 sin cube x here, and there are also 1 minus 2 sin squared x, 1 minus sin squared x. So you can have minus 4 sin cube x plus 4 sin cube x, 8 sin cube x. So cos 2x into 8 sin cube x. Then plus 2 sin x minus 4 sin x plus cos 6. This plus cos 6 doesn't matter. I think I need to check this question again. By the way, please try it. In the meantime, I'll check this question. I have a strong doubt now with this question. With the flow, I have a strong doubt. So please try a bit. Give me 1 minute. I'll check this. Yeah, I did the mistake here. This is minus cosine cube x plus cosine cube x. You don't have any sine cube x. That is where. By the way, one more thing to go with, tan is also okay. We decided by looking at sec 2x not to go for tan. Sec 2x is 1 plus cos 2x. But in our syllabus, you cannot directly apply cos 2x or sin 2x in terms of tan. Then you have to show separately cos 2x is 1 minus tan squared or 1 plus tan squared. Then it will be easier to do this other than converting to sin and cos. You have to start with that, by the way. Then you have to go for the proposition, right? So here, minus cosine cube x plus cosine cube x. Here, after that, 2 sin x and minus cosine x, minus 2 sin x. Here you have cos x. You have cos x. So cos x minus 2 sin x is 0. That is it, ne? Minus cosine cube x plus cosine cube x minus cosine x plus cosine x minus cosine x plus cos x is 0. All right, now let us solve. Now let us solve. Cos 2x is 0 or cos x minus 2 sin x is 0. Here, I'll go put there. Cos 2x is 0. Cos 2x is cos. What is the primary solution for 0? 5 by 2, 90. So 2x is 2 in 5 plus or minus 5 by 2. X is in 5 plus or minus 5 by 4. N is any integer. That is the first part. For the second part, here, cos 6 equals 2 sin x. Cos 6 equals 2 sin x. And x equals half. By the way, for half, you don't have a table value. So let us say the primary solution means beta. Tan x equals tan beta. Therefore, x equals m5 plus beta. Here you have introduced m as an integer. And what about beta? Since it is plus value, you can right away go for inverse notation. And beta is tan inverse. That is it. Clear? So we solved for the general solution. This is how we finalize the answer. Okay, right. So please correct and do the corrections. If you have any doubt, please ask. That is how you need to practice. You have to like before going to the A level exam, you have to practice everything, all the right ways and the wrong ways. I mean, out of the right ways, what is going to be the most suitable way? Yeah, you have to lose nothing. of the marks and save the time as well. That is how much of practice you have to have before going to A level exam. By looking at the A level exam paper, you have to like, I know everything. Everything is familiar for me. That is how. That is the only way you can have it. Right? It's complete. All right. So we are moving to part B. Part B. Prove that 2 cos square theta minus 2 cos square 2 theta is cos 2 theta minus cos 4 theta. 2 cos square theta minus 2 cos square 2 theta is cos 2 theta minus cos 4 theta. Right. So from where we have to start? Median. RX is cos double angle is we need to have from cosine. 2 cos square single angle minus 1 minus 2 cos square, I mean half angle. We have single angle. 2 cos square half angle minus 1. So minus 1 to plus 1. Eventually 2 cos square theta minus 2 cos square 2 theta, which is 12 inches. That is done. And reduce that. Cos 36 minus cos 72 is half. So how to get it done? Here you have just proven this. By looking at this, you can right away say 36 and 72 you have to have as difference. So if you substitute theta to here, it is that cos 2 theta minus cos 4 theta. You think that right away, if I substitute 2 theta as 36, so theta as 18, you can have cos 36 minus cos 72, theta as 18. By the way, the side where you expect the answer is going to be 2 cos square 18 minus 2 square, 2 cos square 36. That is the harder part. Even once the angle gets smaller with the multiples, the answer is harder. So after the proof, what you have to do is you have to think not in that conventional way, but you have to take a risk. Take a risk. What is the risk you are taking? You substitute theta equals 36, then you will have 72 here. Then you have at the same time difference of two squares as well. So you can say substituting substituting theta equals 36. Then you have multiples of 36 into 2, 36 into 4. You can deal with it easier. So 2 cos squared 36 minus 2 cos squared 72 equals cos 36 minus cos, no, theta equals 36. So cos 72 minus cos 144. Right. So 2 out cos 36 minus cos 72 cos 36 plus cos 72 is cos minus cos. And at the same time, you have to think, you have to be smart here. Your target is to have cos 36 minus cos 72. Already it is given as half as well. So cos 36 minus cos 72 is half. By the way, you already have 2 here. Be smart. How to be smart? Cos 72. Right away, change cos 144 without going to CD. Even when you go for CD, you will have the answer. But this is easier. What about cos 144? It is cos 180 minus 36. What about cos 180 minus 36 is minus cos 36. Along with this minus plus cos 36. Plus cos 36. So you can cancel out these two. Therefore, you can say cos 36 minus cos 72 equals half. Okay. Just prove that cos 36 minus cos 72 to be half. So please complete it. Then we have to find cos 36 and cos 72. Think about that. All right, so how to find cos 36 and cos 72? Yeah, how can we have? Yeah, cos 36 and cos 72 after having these. Do they say deduce? Yeah, no, hence. Reduce hence. So we reduce, now you have to use hence means whatever you wrote. They are, you have to think simply. How? You have to like, you have to find the two cos 36 and cos 72 values. So you have to like go for simultaneous equation, but we have only one equation. They say find both. So you have to convert one to the other within the equation. Means, yeah, let us convert 72 to 36 by half time. Now you can say cos 36 minus 2 cos squared 36 minus 1 half angle done equals half. Let us multiply everything with 2 and minus 2 4 cos squared 36 4 cos squared 36 minus 2 cos 36 minus 2 cos 36 minus 2 cos 36 plus 1 is minus 2 and minus 2 is 0. Minus 2 and minus 1, so it is minus 3. Again multiplied by 2 minus 4 cos squared 36. Minus 4 cos squared 36 plus 2 cos 36 plus 2 is 1. Right. Let us bring all the things to the other side. 4 cos squared 36 because I prefer to have the linear coefficient as plus. It doesn't matter if it is minus. 2 cos squared 36. 2 cos squared 36. 4 cos squared 36 minus 2 cos 36 minus 1 0. So yes, you have to find cos 36. Since this is trigonometry, you can use the formula. This is not algebra. Minus b plus or minus b squared minus 4ac over 2a. So cos 36 is going to be 16 20 2 root 5. 2 root 5 2 plus or minus 2 root 5 over a. Going to be 4. You can see cos 36 has to be positive because it is from the it is acute triangle. 36 is acute triangle. This is positive. Cos 36 equals 1 plus root 5 over 4. That is cos 36. Now to find cos 72, you don't need to go for the equation. You already have this. Therefore, cos 72 is cos 36 minus half. 1 plus root 5 by 4 minus half. 4 down. 1 plus root 5 minus 2. Root 5 minus 1 by 4. Cos 72. Cos 36 done. Cos 72. Clear? So that is how we completed up to 12b. So please do the corrections. What you need to do is you have to further try the questions. So you have the remaining parts as 12c and the complete question number 14. In case you have any question, you can ask me in the class. So through WhatsApp, you can ask for the doubts. By the way, keep doing the hard work because today it is 1st July. So you have just July, August, September, October. Just 4 months you have. July, August, September, October. Yeah. Just 4 months you have to study properly towards having 3 A's, not only maths, but also the other two subjects as well. You have to balance. You don't have or you can't have any second to waste. You have to work in every second to be effective. Have your own plan. You don't need to compare yourself with the others. They might have done something different. In the start, yeah, everything is like whatever things happened, that has happened. So you don't need to be worried on that. But you have to find the remedies, find the solutions. Yeah, it went wrong. And you have to, yeah, you have to continue your work well, having a proper plan to yourself, right? Don't give up. Think positive and plan positive, then execute positive. Don't just dream or plan, you have to execute as well, right? So we'll meet with the other paper number 5. For the students coming to the class, they will have the paper at class. Come at the sharp time, and here as well for the online class, come sharp at 6. So for those who join online, I'll give you the paper by the weekend. Then you can complete within the 2 hours and check your progression with the discussion. Right? Bye, everyone. Take care, everyone.